Bismillahirrahmanirrahim. Assalamu alaikum dear viewers. I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So now let's begin. Our today's lecture is about pyridazine and specifically about the basic character of the pyridazine and the different behavior of pyridazines towards electrophilic or nucleophilic species. So first of all, we see the questions that we are going to answer out. The question is, pyridazines are considerably weaker bases than pyridine, and we have to justify or support this statement. So the diazines, the structure of the diazines, let's suppose that is, for example, pyrimidine, that is like this. So the diazines and the pyridazine is like this. Pyridazine, here the nitrogens are at alpha positions or ortho positions, and here in the pyrimidine the nitrogens are at meta positions. So the diazines are essentially monobasic substances. For example, the pyridazine, they are considerably weaker bases than pyridine. The structural formula of pyridine is this one, because here, as we have already discussed, that the pyridine has only one nitrogen that withdraws the electron density from the ring carbons, but here in the case of diazines there are two nitrogens that withdraw the electron density from ring carbons, even more than that in pyridine. So why we call the monobasic character? Because only one nitrogen gets protonated or donates its electron pair. For example, when we have attacked the proton, or we have let this compound to react with the proton, then only one nitrogen gets protonated and it gets converted into N-protocation, or alternatively it is also called as monobasic, because only one nitrogen gets protonated or it offers its lone pair. So we call it as monobasic. So these are essentially monobasic substances, these diazines, and they are considerably weaker bases than pyridine, and the reduction in basicity is believed to be largely a consequence of destabilization of the monoprotonated cation due to a combination of inductive effect and mesomeric withdrawal by the second nitrogen. The inductive and mesomeric withdrawal by the second nitrogen in the case of these diazines, because when one nitrogen has shared its lone pair with any other electrophilic species, then this nitrogen would not offer its electron pair, because it would withdraw the electron density as much as possible, and because it also gets the positive charge in the case of protonation, then it would also has less electron density and it would also withdraw the electron density even more than this one. So because of this character, the inductive and mesomerically these nitrogens would withdraw the electron density. So these two parameters make these diazines monobasic or less basic as compared to pyridine. If we see the examples, in the case of this pyrimidine, under normal conditions, when it reacts with the alkyl halides, for example, methyl iodide under methanol at room temperature, then only monobasic character is being shown by this. Here it would form the methyl salt of quaternary or methyl salt of pyrimidinium ion, and to stabilize this cationic species, this iodide would be present over here. So under normal conditions, only monobasic character would be shown by this, or it would form monoprotonated cation. And also in the case of diazines, it also reacts. For example, let's see that we have introduced the methyl group at its 3 position. This is 1, 2 and 3 position. So this is called as 3-methyl pyridazine. Because this methyl group would also donate the electron density. So we may say that in this case, this methyl group is donating electron density, so this nitrogen may it possible for both of these nitrogens to get protonated. So let's see the case. It reacts with the alkyl halide and still only monoprotonated cation is formed. Here it is methyl, and in this case only either when only this nitrogen would get protonated, here positive charge and here iodide ion, and the second product is here it is methyl, and at this nitrogen there is also a methyl group. So here there is a positive charge on this nitrogen. So both of these products may form either this one and also this one, but the proportion for these is 70% this product would be formed and 30% of this product would be formed. So now the nitrogen 1 gets alkylated in higher proportion, but the nitrogen 2, here we write them as nitrogen 1 and nitrogen 2. Nitrogen 1 is 70% and nitrogen 2 gets alkylated 30%. So 7 to 3 is the ratio for their yield. So we may say that N1 gets protonated even in the case that N2 has the higher electron density in the case of 3-methyl pyridazine. So the question arises here that 3-methyl pyridazine alkylates mainly at nitrogen 1, even though nitrogen 2 is more electron rich, or the second statement may be formed as the pyridazine alkylates to yield monosubstituted product while pyrimidine yields disubstituted product. So these are the cases where only monosubstituted product is formed. But there is an exceptional case also where a more reactive trialkyl oxonium, this is trialkyl oxonium, boron tetrafluoride or tetrafluoroborates, BF4 negative. This is called as trialkyl oxonium tetrafluoroborates. These are the most reactive species, and these convert this pyrimidine into diquaternary salts under the presence of this Cl, CH2 twice, Cl under reflux condition, and it would be converted into this product. Here there would be an ethyl group with positive charge on this nitrogen and also positive charge on this nitrogen. Anal ethyl group would be here. Because there are ethyl groups, so one ethyl would be linked with this nitrogen and one. So in this case we may say that it is the disubstituted product. Okay, the pyridazine forms monosubstituted product, but pyrimidine may also form disubstituted product. So here there are the two reasons for which these questions may be satisfied. Why these cases appear? You may write down, because there are three factors. The one is alpha effect. What is alpha effect? The lone pair interaction between these two nitrogens is called as alpha effect. Because here there is a methyl group in between two nitrogens in the case of pyrimidine. So the alpha effect is weaker in the case of pyrimidine but stronger in the case of pyridazine. The higher the alpha effect, the lower the tendency for disubstituted product. Right? When alpha effect is higher, the only monosubstituted product would be formed, because this lone pair interaction would rule out the disubstituted product for these pyridazines. And the other case is unsymmetrically substituted diazenes can give rise to two isomeric quaternary salts. The substituents influence the orientation mainly by steric and inductive effect. So when we talk about the steric effect, then if both of these nitrogens get alkylated, and here there is also a methyl group, then there would be much more steric hindrance, and that would destabilize this disubstituted product or this disubstituted pyridazine. But here there is enough distance between these two nitrogens, and if both of these nitrogens in the case of pyrimidine gets alkylated to form the disubstituted product, still there is less steric hindrance, less alpha effect, less steric effect, so the pyrimidines may form the disubstituted product, and also inductively it is all sported. But in the case of pyridazines, The higher the alpha effect, the stronger is steric hindrance or steric effect. So only monoprotonated or only monosubstituted product is formed in the case of pyridazines. So steric and inductive effect would play their roles in these cases rather than the mesomeric effect. The mesomeric effect would have lesser effect as compared to these two. And no doubt this nitrogen 2 is highly electron rich because of the presence of this methyl group that is inductively electron donating, but still due to influence of this alpha effect and steric hindrance, the N2 cannot be or N2 cannot be highly favorable, and the N1 gets alkylated at a higher yield. Okay, so the alpha effect and steric hindrance dominate to form, or these alpha effect and steric hindrance dominate to hinder this N2 to get alkylated. That is why only N1 gets alkylated to form monosubstituted product in the case of pyridazine. So thank you very much for watching this video. Allah Hafiz, and please subscribe my channel and press bell icon.